Hi everyone, welcome back to our channel. Today we are going to solve problem number 24 is construct the phasor and impedance triangle diagram as well as impedance triangle and determine the circuit constants R as well as L for the given instantaneous voltages which are function of time. So from here I can write down these are instantaneous voltage. I can write down the voltage V is equal to RMS, which is nothing but we're going to get it as 150 is the maximum divided by root 2 at an angle of 50 is the RMS values. Okay, so here the RMS current I is equal to this is so you can see here this is the standard format I maximum sine of omega t minus 5. So when you compare here, this is the maximum value. So there's nothing but 5 divided by root 2 with an angle of 5. That 5 value is how much? Minus 25 degrees. Therefore, the V we are going to get by doing with your calculator 106.06 at an angle of 50 degrees, and current I we are going to get 5 divided by root 3, which is 3.53 at an angle of minus 25 degrees. So in order to find the parameters, I'm going to write down the impedance Z is equal to V by I. So the value of V is equal to 106.06 at an angle of 50 divided by 3.53 at an angle of minus 25. So when you are converting this r comma then just you can divide it, then you are going to get 30 at an angle of 50. This minus will go up, which is nothing but 75 degrees. When you convert this into rectangular form, then you are going to get 7.76 plus j 28.977. So the impedance offered in a series RL circuit is R plus JXL. Okay, so the value of so now this is the total impedance offered. So from this impedance, first what I have to draw is the phasor diagram we need to draw. Okay, so phasor diagram. Okay, when you are drawing this phasor diagram, we should draw with respect to only the polar form, and this polar form and these quantities will be in RMS quantity. Okay, now let's try to draw for voltage initially by taking this as a reference. Okay, let's try to take some reference 0 and see this voltage. This is maintaining an magnitude of 106.06, making an angle of 50 degrees. Okay, so the magnitude is 106.06 volts, and it maintains and it rotates in clockwise direction, making an angle of 50 degrees. Yeah. This is the voltage, and if you see the current, the magnitude is very less, and you can see this magnitude is very less, and just it makes only 25 degrees. Okay, so here it makes 25 degrees, and magnitude it makes approximately 3.53 at an angle of minus 25. So this is the magnitude 3.53. Before the overall angle made, the phase difference of cos phi is 50 minus 25, which is nothing but approximately we are going to get 50 minus of minus 25, you are going to get 75. If you perform cos of 75, then you are going to get the power factor which makes between the voltage. Just use your calculator and just perform 75, then you will get the power factor which is 0.25 lag. Why? Because inductive load. This is how to draw the phasor diagram. And next one, the question it is asked is draw the impedance diagram. How to draw the impedance diagram is, so this is R. Okay, we have to construct the R, which is 7.76 ohms, which is flowing in this direction. So this is XL. So XL at an angle of how much? 90. So plus 90 means it will travel in this direction, and it makes an angle of plus 90, and magnitude which is nothing but it is J 28.977. Okay, so when you join this, then you're going to get Z, where Z is equal to 7.76 plus J 28.977 is the diagram. So this is R, this is plus JXL, and this is the impedance of the form R plus JXL. Therefore, this diagram is called as the impedance diagram. So successfully what the examiner asked, we are able to find the resistance and the impedances, and the phasor diagram is drawn and impedance diagram also be drawn, and circuit constants. So you can see here the third question he has asked is the circuit constants R is equal to 7.76 ohm and plus J X L is equal to ohms is equal to J 28.977. Okay, so when you do it, plus J, XL can be written as omega L, which is 2 pi FL is equal to J 28.977. But already in the problem, what is given? Omega is given, the omega value is 5000. So just substitute J 5000 is equal to J 28.977 into L. So automatically, if you divide that value, L value you are going to get as 5.795 millihenry. So successfully we find all the three constants what is asked in the problem. We draw the phasor diagram, we draw the impedance diagram, and we find the constants RL. So well, it is not clearly given. You will ask, it is not clearly given which type of constants you had initially determined. When you get minus 5, you can understand this is a which type of load R and L are connected in series. Based on that phase angle, you have to calculate the constant. This is all about how to draw the phasor diagram and impedance diagram. If you feel my explanation is good, please give a like to the video, and please share this video for your students or your friends who are studying the same subjects. Still, if you have any doubt, let me know in the comment section. And if you're watching the channel for the first time, subscribe to my channel with the name KV Tulasi Ram. Thank you for watching. We'll meet in another video. Yours Ram.